All right, let's look at one more example here. Z is equal to xy. X is r squared and y is s cubed. So our z here is dependent on x and y. X depends on r only. It's r squared, and y depends on s only. It's s cubed. And then we want d2y dr ds. So this is saying take dz ds at right derivative and then do the partial with respect to r. So you got two partials there. So here we've got dz dx, that's a partial, and then dx dr, and then we've got dz dy, a partial, times dy ds. So then our partial here, dz ds, we're going to use the two branches that end in s, so dz dy dy ds. So y derivative of z is just going to be x, and then dy ds, that's just going to be 3s squared. And then if we want to, we can write x here as r squared. So this is going to be r squared times 3s squared. So that's 3r squared s squared. And we want partial of that with respect to r. So we want to take partial with respect to r of the 3r squared s squared. So here we needed to change everything to r and s. We needed to do this plug-in here for x in terms of r because we had to take one more derivative. So now our derivative here, so r is our variable, 3s squared is a constant. So 3s squared, that constant out in front, we multiply it by 2, which could be 6s squared, and then decrease your exponent on r, so times r. Or if you want, 6r squared. So again, you can make up any chain rule you want, just sketch your tree diagram.